Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem ID 2762, continuous subarrays. It's a very good variable sliding window problem and asked in companies like Google, Amazon, Adobe, Uber. Okay, let's have a look on the problem statement. In this question, we are given a zero index integer array nums, and a subarray of nums is called continuous if it is following this condition. We'll have a look on this later, and return the total number of continuous subarrays. A subarray is continuous, non-empty sequence of element within an array. It is saying that we are given an integer array nums and we have to return the count of all the continuous subarray. Count of all the continuous subarray. Here, I hope you understand what is a subarray. Subarray is a piece, or if I cut a slice of this array, it will become subarray. Contiguous set of elements. Let's say in this case, 4 to 4 is a subarray, something like this. And count of all the continuous subarray. Now we understand what is subarrays. What is continuous subarray? It is saying that if I pick any subarray from index I to j, right? Then difference between any of the two pair from that subarray should not cross 2. Let's say in this example, if I pick a subarray called 4 to 4, 4 to 4, I can pick any two elements. Let's say I1 and I2 are the indices of that pair. Then difference between the values of these two elements should not cross 2. Let's say if I pick 4 and 4, difference is 0. That is valid. If I pick 2 and 4, difference is 2. It is not crossing 2. It is valid. If it was something like 0 instead of 2, then the difference between 0 and 4 is 4. It is crossing 2. So this subarray is not a valid continuous subarray. Okay, I hope you understood. So this was our problem statement. Given an integer array, find the count of all the continuous subarray. And subarray is this, where difference between any of the two elements in that array, subarray, is not crossing 2. We have understood the problem statement. Here I will need to further investigate over this continuous subarray. Let's say this is the subarray and I want to know whether this subarray is continuous or not. I need to pick two elements. Let's say two elements are I and j. The values of two elements, their magnitude of the difference should be less than or equal to 2. If it means if I pick two items which are extreme of this subarray, what are the extreme elements? If I pick the minimum and the maximum element, if I check the difference between minimum and a maximum element, no other pair is going to have difference more than this. I hope you are getting. So here in this subarray, minimum value is 2, maximum value is 5. If I check the difference between these two values, I will be getting what is the maximum difference between the two values of any pair of this subarray. Okay, this difference is 3. It means it is not a valid continuous subarray. So this subarray is not valid. If I pick 4 to 4, what is the minimum element? Minimum element is 2. And what is the maximum element? Maximum element is 4. Difference between minimum and maximum is 2, which is less than or equal to 2. If this pair is valid, it means all the pair are going to be valid. So this is a valid continuous subarray. And this subarray will be considered in my answer, and my answer count will be plus equal to 1. I just need to return the count of all the valid continuous subarray. Now let's try to see how we can solve this problem. Here, first of all, I need to get subarrays, and those subarrays I need to see whether that subarray is continuous or not. Firstly, let me ask you a question. How many subarray I can have of this array? That subarray can be this 5, 4, 2, 4. And this 5, 4 is also one subarray. 4, 2 is also one. 2, 4 is also one. And this 5, 4, 2 and 4, 2, 4. And the end like this. So there is one size subarray are 4. 2 size subarray are 3. 3 size subarray are 2. 4 size subarray is 1. N into n plus 1 by 2. these many number of subarrays we have. And from this subarray, if I do or try to think brute force way, I will just get all the subarrays and I will see whether that subarray is valid or not. If that is valid, I will increment my counter. Otherwise, I will just discard that subarray. We have all the subarray. Now, if you try to do this programmatically, what is the time you are going to take? How we can do it? Firstly, let's say this subarray is starting with 5, this is starting with 5, this is starting with 5, and this is starting with 5. I can process all the subarrays starting with index 0, then starting with index 1, index 2, and index 4, like this. So what I can do is from index 0 to n minus 1. If my subarray is starting with this index, and if my subarray is ending at this index, j will go from I to n minus 1. So this nested loop structure is going to give me all the subarrays from length I to j, both inclusive. Got it? And how you can know that the subarray is valid or not? This nested structure is going to take n square time. And now this is my processing. Processing will also take some time. And to make the processing efficiently, what we discussed in the previous part, that I need to know the maximum difference between any pair. So if I want to know the maximum difference, I will just pick minimum element and the maximum element. If minimum element of that subarray, maximum element of the subarray are having difference less than equal to 2, it means all the pairs are going to have valid difference. So this is my loop and this is my processing from index I to j. What I can do is, if while doing the iteration, I keep track of the minimum element and the maximum element of that window from I to j. If I keep track of these values when I'm doing the iteration, and I will be able to figure out in order of one time whether this subarray is valid or not. How we can do that? If maximum value minus minimum value is less than equal to 2, then this subarray from I to j is valid, otherwise discard this subarray. And this processing I can do it order of one time. So the processing is done in order of one time, and this iterations is going to take order of n square time. I will be able to achieve this solution in order of n square time. So what is the time complexity of this approach? N square. And what about the space complexity? Are you taking any extra space? No, just two variables, order of 1. So this is the time and space complexity if we are approaching it by calculating all the subarrays. So initially I'm starting my subarray from I, and I will keep on doing in this direction, keep on incrementing my j until I am achieving a valid subarray. Let's say from I equal to 0 to j equal to 0, I will see. Then j equal to 1 I will see. From 0 to 1, 0 to 2 I will see. If let's say 0 to 2 is invalid, it means there is no need to go further. No need to check another subarray starting with I. Just break the inner loop. In short, considering all the subarrays starting with I. I am trying to explain this solution in a very detailed manner so that it will improve building your base. So you are perfectly fine with this brute force approach. This is not the brute force. We have done some optimization while calculating or doing the processing. But yeah, this n square is not going to pass all the test cases to 10 or 20 cases, which are going to give me TLE, time limit exceeded. If it is TLE in this way, before that, let me show you the code for that. This is the code I have written. Here what I am doing is, this is my outer loop, checking all the subarrays starting with index I and ending with index j. And when I am doing the iteration on the inner loop, I will keep track of the minimum and maximum element. Minimum maximum I initializing with the current element, starting element. Then with every iteration, I will update my min and max, and if my min and max are valid pair, maximum minus min less than equal to 2, then it is a valid solution. And then this subarray will be the part of my answer. Answer is incremented by 1. Otherwise, there is no need to cover other subarray starting with I. Then break is important. So in this way, covering all the subarrays starting with I, and this is my answer, I am returning it. Once if I try to submit this problem, this is fine because it is an n-square solution, but it is not going to cover all the test cases. This will give me time limit exceeded, not working on a very large input cases. So how we can improve it further? So we are going to improve it further using the concept of variable sliding window. Let me show you how. We are taking the same example 5, 4, 2, 4. This is my given nums array and we are going to apply variable sliding window on this question. Why? Because our previous approach of n-square time is not passing all the test cases. Here for every window is like contiguous, like this, starting from any index, ending at any index. Let's say I and j are the variables to hold my current window. So whenever there is a sliding window problem, we need to make some things in our mind. Here the note from my side is that whenever you are doing any iteration, how we approach the sliding window problem sometimes is that we have one pointer I resting somewhere, let's say on the left pointer, and we increment our current pointer or right pointer or j pointer. J pointer we are using to do the iteration. Okay, and when we do the iteration, whenever we are moving ahead, we are having some sliding window previously from previous iteration. Okay, so whenever we are getting a window from previous iteration, we have to assume that that is definitely valid. So this is the rule to make a sliding window problem. Okay, let's say we have processed I to j. This window is processed and we are moving ahead. To move ahead, we have to increment j pointer by 1. We incremented the j pointer. It means the previous window is I to j. When I am at I to j plus 1, my previous window is this. I have to assume that this is definitely a valid window, and we have to write the code accordingly so that this will be true. So window from previous step is valid one. So this you have to make sure. And these are the main 3 steps of every sliding window problem. Firstly, I am incrementing my j pointer or right pointer. So consider the next new element. Consider j in my window. From I to j. This was my previous sliding window. And my new sliding window is I to j plus 1. From this to this, I only added one element. My previous window was valid, and after introduction of new element, my window can get disturbed. So my 3 rules are: first of all, consider one element. This is my first rule. Consider j in my window. And if you are considering a new element, your window can get disturbed. So make it valid again. Right? Introducing one element in my window and make the window valid again, because let's say we have window something like this, 424. 424 is valid because minimum element is 2, maximum element is 4. Difference is less than equal to 2. If the new element is, let's say 9, my window will become 4249. This 4249 is not a valid window because minimum is 2, maximum is 9, the delta is not less than equal to 2. So this introduction of new element is making it invalid. And how we can make it valid? To make it valid, just increment your left pointer, because we have to maintain 2 pointers. One is left side of the window, right side of the window. Keep incrementing the right side of the window, and when the window is getting invalidated, they increment the left pointer. This is the step 1 everyone should do in their sliding window problem. Consider j in the next window, then make it valid again. And once you have made it valid, capture the result. So after this, when you are going to the next iteration, you are giving a valid window to the next code. So these are the 3 steps you have to keep in mind. If you are not able to understand it, just try to watch this part again. Now we are going to implement on my example 5424. This is the array given to us and I have to maintain the pointer or window. Let's say my window is from I to j. What should be the initial values? Initially let's call it 0 0. My I is here and j is also here. My window is from 0 to 0. This is your right pointer, j pointer. Firstly, consider j pointer in your answer. If I consider j pointer in my answer will be something like this. Not answer, it is subarray. This is the subarray. And then second step is that step 1 is done. Step 2 is I need to see whether this window is still valid or not. To make that validation, I must have minimum element and the maximum element of this window. Minimum element is 5, maximum element is 5. It is valid window. So if it is valid, just keep on going ahead. Okay. Now this window is valid. So my step 2 is also done. I am at step 3. And what is step 3? Step 3 is capturing result. Now what is result here? Result is all the valid continuous subarrays ending at j. Okay. My j pointer is iterating from 0 to n minus 1. Initially it is 0 0, 0 1, 0 2, something like that. And my step 1 is introducing j in my window, making the window valid and then capturing the result. What is result? Result is all the valid continuous subarray ending at j. And what is the value of that? My window is I to j. This is my window. And I want all the subarrays which are valid. This window itself is valid. If I consider any example of valid window, so this is a valid window and my j is at this position. So all the subarrays ending at j are this, this and this. Let's say this is the I value. If I is 0 and j will be 2, then how many number of valid subarrays I am having? From this range, it will be j minus I plus 1, 2 minus 0 plus 1. So whenever I am at j and the window is valid from I to j, the total number of valid subarrays would be j minus I plus 1. Okay. So step 3 is from I to j, my count will be incremented by j minus I plus 1. This is I'm capturing the result. So in this way, you keep on incrementing your window. First step is that introduce 4. So now for the first step, I is 0, j is 0, total number of valid subarrays 0 minus 0 plus 1, which is 1. 1 will be added to my answer. When I will increment j will be coming here and this window is also valid. If it is not valid, I will try to make it valid by incrementing my left pointer. But here in this case, it is valid. From I to j, it is valid. J value is 1, I value is 0. Step 1 is introducing 4 in the result. That is fine. I just incremented a j. And second step is make the window valid. Window is also valid. How we are making window valid? The maximum element and the minimum element is having delta less than equal to 2. And 3 step is capturing result. So here these 3 steps we are able to implement. But first step is fine, third step is fine. And what about the second step? In the second step, I require minimum value and the maximum value. So let's say I'm shrinking the window. Shrinking the window is incrementing I pointer, left pointer. In that case, I might have to iterate over the window again to capture what is minimum value, what is maximum value. So that is going to take order of n time again. So it will ultimately lead to n-square solution. So we need to think, is there any better way to keep track of the minimum element and the maximum element in that window? When we are moving from I to j, there are some elements and those elements are coming maybe any number of time. So if I maintain some kind of map where the element is value and it is its frequency. Let's say 2 is coming 1 time, 3 is coming 2 times, 4 is coming 2 times. So when I will increment I, if this value is 2, I will just decrement 2 from it. 2 will coming 0 time. And if it is 0, just discard it from the map. And this map is fine. But if I try to make this map sorted means all the entries are sorted in the order of keys. In short, I am calling it tree map. Tree map is sorted if you are using Java, or you can prefer any other language, but you have to use sorted map. If you are using sorted map, you will be able to get what key is the minimum value, what is the maximum key. Minimum key and the maximum key are the minimum and maximum element, and we can capture whether the window is valid or not. Okay. If it is getting confusing, just try to watch the portion again. So from I to J, first step is introducing J and then make see whether the window is valid or not. If window is not valid, you have to increment J I pointer, left pointer. When you are incrementing left pointer, you are discarding a value from the window. Discarding a value from the window make changes to your min value and maximum value. To make that operation in order of one time, I have introduced this tree map. Because using tree map, I will be able to get what is the minimum key and maximum key in a constant time. So this much we have to do. So in this sliding window, my J pointer is going from 0 to n-1. And when I have to shrinken the sliding window, I pointer can also go from 0 to n-1. So ultimately, this is my J pointer, this is my I pointer, and I will always be less than equal to J. It means it is a single iteration ultimately. And this tree map is going to store some values. Here, let me ask you a question. Let's say maximum value is B and minimum value is A. So what are the possible values? Let's say this can be 1, 0, 1, 2. No other possibilities are there. It means what can be the maximum size of this map, tree map? Maximum size of tree map is that they are holding keys in order, and as we are not allowed to hold keys, minimum key and maximum key having delta more than 2, it means that the tree map size will always be maximum 3 or minimum than that. So my sliding window is going to take order of n time. Okay, because we are just doing one pass using 2 pointers. And this tree map is going to store 3 elements at max. It's a constant value, and we are adding elements to the tree map. Adding element to the tree map is log n operation. If at max you are adding 3, if at max your size of the tree map is 3, so what is the time taking to add a value in the tree map or remove a value from the tree map? That is log of 3. It's a constant value. So I'm not going to consider it in the time complexity. So what is the overall time complexity of my approach? My variable sliding window approach is order of n. And what is the space? You might say that we are taking a new tree map in this case. The tree map size can go from 3 at max. So it will be order of 1. So you can call it constant space and linear time solution. Previously, we found out n square time, and this is linear time. So it's a very good optimization using variable sliding window, and this question is itself a very good question asked in Google. So make sure you are covering it and solving and submitting the solution. Now let's have a look on the code of this approach. First of all, I have taken a tree map so that I am able to get what is the minimum element, what is the maximum element in that current window. I will just keep track of the counter or frequency of every element in a particular window. So if I know every single element of that window, I will be able to get the minimum and the maximum in a constant time. Why constant time? Because this tree map size will not go beyond any specific value, because the difference between any 2 element of a valid window is not crossing 2. So it will be something like 0, 1, 2. If 0, 1, 2, 3 is also available somewhere, it will not be in the map. And then this is a tree map. Tree map operation you can consider in a constant time, and this is my window from I to J. I is my left pointer, J is my right pointer, and this is the length of the array. This to capture the answer. This is the main logic. where we are applying three major steps of sliding window. First one, include the current element. Current element means the right pointer, J pointer, is going from 0 to n-1. So include the current element. If after including the current element it is disturbing my sliding window, then I will correct my sliding window. How? Like incrementing the left pointer. If the total, if the minimum element and the maximum element difference is crossing 2, it means the window is not valid. Make it valid by shorten it from the left side. When we are removing element from the left side, if any element count is 0, we have to remove the entry as well, so that we can pick the entry, first entry, last entry associated with the smallest element and maximum element. Okay, so step 1 was include that element. Step 2 was make the window valid. Step 3 was capture the answer, and in the end capture all the continuous subarray we have captured so far. Sample test cases were worked on my approach. I'm submitting the problem directly. It is submitted successfully. I hope you have understood the approach, and I will be attaching the solution in the description below so you can have a look and get the idea. Okay, thank you guys. Thanks for watching. Bye bye.